So hi everybody. So let's continue with the questions that we were discussing. So this is the next question in the sequence. This question is from the topic permutations and combinations. And the question asks, how many six-letter words can be created using the letters of the word mathematics? So we have to use the letters which are in this word mathematics, and we have to create six-letter words, and we have to tell how many such words can be created, and the words can be meaningless. So there is not any restriction if the resultant word has to have a meaning or not. So we can create any word. Let me give an example. So example can be, let's say we create this word MATHEM. This word has six letters, and this is a valid selection. Okay, this is a valid creation. So we have to calculate these words. Okay, so let's start with the solution. So the first step in any PNC, in any probability or in any permutation or combination question is to find what is the nature of things that we are trying to arrange or select. Okay, so here the values I can see, some of the values are repeating. M and M are repetitive. Okay, and some values are distinct. This is T is distinct. Okay, so what I can say is, okay, let me write step one. Step one will be identify the nature of things you are trying to arrange slash select. So this question over here, the values over here belongs to the category which I call non-distinct and non-repetitive, which is INF, infinite repetitions, which are not allowed. So why I'm calling this is, let me explain. So non-distinct, here the things I can use is, I have M, then I have another M as well. So things are not distinct over here, which I have to use to create my words. So these two values are same, so that's why I'm calling them non-distinct. I have double M's, I have double A's. You can see over here, one A is over here, one A is over here. Then I have double T's as well. One T is over here, one T is over here. Then I have single H, then I have single E, then I have single I, then I have single C, then I have single S. So some of the values are distinct and some of the values are not distinct. Okay, like M is not distinct. Let's count once, 2, 4, 6 and 5 over here. So 11 values, and let's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so we have all 11 values. And why I am calling it as non-repetitive? So by non-repetitive I mean infinite repetition. So we cannot create words where we can select all. So M can come in any word only two times, because it is available only two times now. So H can come only one time. So we cannot have a word which looks like this. Example, M M M M M M. So this six letter word would not be considered as a correct creation. Okay, so that's why I'm calling it non-repetitive. By repetitive I'm taking in consideration only the infinite repetitions that happen. Okay, so since we have identified this is a non-distinct, non-repetitive case, now we know that such questions are solvable using two approaches. So approach number one is, if we have to go case, we have to calculate case by case, or we can say case making. Case making is the first approach over here, and approach 2 over here is approach to over here is multinomial theorem. Nomial theorem. I'm preferring multinomial theorem over here in this question because uh, I think we would have a lot many cases, because one case can be we have to select only 2m, one case can be we have to select 2m and 2a's as well, one case can be we have to select 2m, 2a, 2t. So there would be a lot many cases, and I think this hassle would be saved if we use multinomial theorem over here. Okay, so let's try to solve this question using multinomial theorem. Okay, so what we have to do is step 2, apply multinomial theorem. Okay, so let me write the input as well. We have double 2 double m double a double t, and then we have h e I c s. So these two are repeating and these are distinct. Okay, so now what we have to do is, since we have to create a 6-lettered word, so we would have to find coefficient of x to power 6 in the multinomial expression. Let's try to write down this expression. Okay, so first input variable, so we have the first input variable is, first variable can be m. Okay, so we are introducing a variable x that will represent our input values. Okay, so m is coming 2 times, so we can write it as x to the power 0 plus x to the power 1. So we have to continue this addition till the highest, till the power of m. So m is coming 2 times, so we write x to the power 0 to x to the power 1 plus x to the power 2. Okay, similarly a comes 2 times, so same thing would be written for a as well, x to the power 0, x to the power 1 plus x to the power 2. Similarly t comes also 2 times, so same thing would be written for t as well, x to the power square. Okay, and HEICS, so we would have to write this expression for h. So this will be x to the power 0 plus x to the power 1. This is for h, x to the power 0 plus x to the power 1. This is for I, HE. Okay, let me write it. This is for m, this is for a, this is for t, this is for h, this is for e, and then we have to continue for I, x to the power 0 plus x to the power 1, x to the power 0 plus x to the power 1 for, this is for HE, this is for, let me write I, this is for C, and let me write for one more, x to the power 0 plus x to the power 1, this is for S. So this is our total expression. Okay, so let's try to simplify it a little bit. We are getting x to the power 0 plus x to the power 1 plus x to the power 2. This is coming 3 times, so we write cube over here, and then we have x to the power 0 plus x to the power 1. This is coming 1 2 3 4 5 times, so we write 5 over here. Now since the arrangement, not only the selection but also the arrangement of the words count in the final result. Okay, so what I'm saying is, this is a word but this is another word. If we just switch the values of a and m, so a comes first in the second expression and a comes second in the first expression, so these two are different words, so we would have to count the permutations. So for counting permutations using multinomial theorem, what we do is, we first identify how many letter word we have to create. So we have to create 6-lettered word, so we multiply it with 6 factorial over here. Then for the words that are repeating, so this has to be divided by 0 factorial, this has to be divided by 1 factorial, and this has to be divided by 2 factorial. This is done to this is done to avoid double counting the cases where two m's are repeating or two a are repeating and two t's are repeating. Let me write down. So this word a t MMATHE, and this word, this is first time, this is second time, and this word MMATHE, this is first M, this is second M, and this is second M, this is first M. These two words are the same. If we will not divide it by 2 factorial, what will happen is these two words will be counted as two different words and we would have double counting issue. So this is done. Now what we have to do is we just have to calculate coefficient of x to the power 6 in this expression. So this is the thing, this is the task we have to do. Okay, let me highlight steps for you so that it's easier for you to grasp. Okay, let's go for step 3. Let me align it. So here, line step 3, calculating coefficients of x to the power 6. Okay, so what was the expression that we have? We have 6 factorial into x to the power 0 divided by 0 factorial plus x to the power 1 divided by 1 factorial plus x square by 2 factorial. This was whole cubed, and x to the power 0 by 0 factorial plus x to the power 1 by 1 factorial. This was to the power 5. Now let's try to simplify it. 6 factorial, x to the power 0 is nothing but 1 and 0 factorial is also 1. X to the power 1 is x itself, and this is x square by 2. This is whole cube, and this becomes 1 plus x to the power 5. So this is the simplified expression. Now let's try to open this cube using the cubic identity. So 6 factorial over here, this will be 1 plus x whole cube. Then let's write the cube of this. This will be x square by 2 whole cube, which is x to the power 6 by 8. Let's write the cube of the next term. Next term will be 3 into first term whole square into the second term, x square by 2. And let's write the final term, 3 into first term into second term whole square, x to the power 4 by 4. And this whole has to be multiplied with 1 plus x to the power 5. Let's multiply this 1 plus x to the power 5 with all the terms inside. So we get 6 factorial by 1 plus x to the power 5 and 3 makes 8. Then we have x to the power 6 by 8, and we got 1 plus x to the power 5, which has come and multiplied with this. Okay, now next term we have 3 by 2 x square, and we have 1 plus x whole square and 1 plus x to the power 5. This becomes 1 plus x to the power 7. And finally we have 3 by 4 x to the power 4, and this is 1 plus x and this is 1 plus x to the power 5th. So this becomes 1 plus x to the power 6. Okay, so this is our expression. I hope you could see it. Okay, so what we are going to do is, now we have to calculate the coefficient of x to the power 6 from each of these expressions and do the required algebra, do the required arithmetic. Okay, so the coefficient of x to the power 6 in this expression would be nothing but 8c6. It would be this value. Okay, and this 1 by 8 is taken as it is. The coefficient, we already have x to the power 6 over here. So from here we would require 1 or x to the power 0. So the coefficient of 1 in 1 plus x to the power 5 is 1 itself. So it has to be multiplied with 1. Then the next term is 3 by 2. We have x square over here and we have to calculate the coefficient of x to the power 6. So we are required to calculate coefficient of x to the power 4, which has to come from this 1 plus x to the power 7. So x to the power 4 coefficient in 1 plus x to the power 7 is nothing but 7 c and 4. Okay, so this is the coefficient, and let's write the final 3 by 4 into. So we already have x to the power 4. We are required to calculate x square over here, coefficient of x square, and the coefficient of x square would be nothing but 6c2. Okay, let me once check. So x is 6 and 1 by 8 into 1, 3 by 2 into 7c4, and 3 by 4 into 62. Okay, so I think this is correct. Now let's try to simplify this by 6 factorial. Okay, by 6 factorial, and we have, how much is 8c? 8c6. 8c6 is nothing but 8 into 7 by 2. So this is the value. This is 1 by 8. This is 3 by 2 into, how much is 7c4? 7c4 is equal to, we know that na, NCR is equal to NC n minus R. I'm using it. So 7c4 is nothing but 7c3. So 7c4 is equal to 7c3. And how will we calculate 7c3? 7c3 will be calculated 7 into 6 into 5 divided by 3 factorial. Okay. And 3 by 4 into 62, expand 6 twice and then divide by 2 we divide by 2 factorial, but since 2 factorial is 2 itself, so 2 is also correct over here. So 6 factorial into this 2 and this 8, this becomes 4, so this overall becomes 28, plus this becomes 1 by 8, plus this becomes, so 3 factorial is equal to 6, so this value is 6 and this 6 get cancelled above, and we get 7 5s are 35, 35 3s are 105, 105 by 2 is our value we are getting over here. And the next value that we are getting is, this is 2 factorial, this is 4 factorial, so this 2 becomes 3, this 6 becomes 3, 9 into 5, 45, 45 by 4, this is the final value. Now 6 factorial is nothing but 720, isn't it? 5 factorial, 4 factorial is 24, 5 factorial is 24 times 5, 120, and 6 factorial is 120 into 6, that's 720. Okay, so let's multiply 720 with each of these terms. 120 into 28, 720 by 8, 720 into 105 by 2, and 720 into 45 by 4. Okay, let's try to simplify. So this value becomes 720 into 28. This value becomes 720 by 8 is nothing but 90. This value becomes 360 into 105. And this value becomes 720 by 4 is nothing but 180. 180 into 45. Now we can multiply, and let me multiply for you guys. Okay. So how much is 720 into 28 is nothing but 0. 2 8s are 16 and 7 8s are 56. This is 57 and this is 0, 4 and 14. This becomes 0, 6. This is 11. 11. This is 19 and this is 20. This first value is 2160. 2160. Second value is 90. Third value is 105 into 36. So let's calculate this. 6 5s are 30. Okay, 3 over here, 3 down. 6 on the 630 is the value over here. Okay, and 3 5 are 15, 1 and 3 0 8 7 3780 780 and 10, which is coming from this 360, so double zero. So because it was into 10 also, no? It was 360 into 105. Okay, so final value is 180 into 45. So let's first calculate 18 into 45. So I know we can write it as 9 into 90, which is 8110, and one more zero from 180, so 8100. Okay, so now let's add up all these values. 20 160, 90, 37 800, 81 8100. Okay, so this is the value 0 6, this is 15 1 8 9 10 11 8 8 16 2 3 5 6. So the total number of words becomes 150. Okay, so the number of 6-lettered words that can be created using letters of word mathematics is equal to 150. So this is the solution.